Hi everyone, welcome back to our YouTube channel. Today we'll be looking at the development of the atom. How did we get from here to here? How did we get from this spherical structure to the one we're more familiar with today, the electron shell structure? In this video, we'll be looking at the scientists involved and their model. We'll be looking at the scattering experiment, and we'll be looking at why new evidence from this led to a change in the atomic model. Before the discovery of the electron, atoms were thought of as tiny spheres that could not be further divided. As scientists gathered new experimental evidence, they developed new atomic models. The scientists involved in the development of the atom are John Dalton, who came up with the spherical model; J.J. Tompson, he came up with the plum pudding model. There's Geiger and Marsden. They did not propose a model, however, they did the scattering experiment, and Ernest Rutherford used their results and developed his nuclear model. Then there's Niels Bohr, who came up with the electron shell model, and James Chadwick developed on this with his discovery of the nucleus. Let's now have a look at John Dalton. He came up with the spherical model, which looked something like this. In the 1800s, John Dalton published his ideas of the atom. He thought that all matter was made up of tiny particles called atoms. He also proposed that atoms are solid spheres that cannot be broken down into anything simpler. According to Dalton, all the atoms of an element are identical to each other and different from the atoms of other elements. He also stated that atoms are rearranged in a chemical reaction, and finally, compounds are formed when two or more different kinds of atoms join together. Now, parts of Dalton's theory had to be modified based on the discovery of subatomic particles and isotopes. Pause the video and try to identify the points that were modified. If you stated point number 2 and point number 3, then you are correct. Atoms are solid spheres and cannot be broken down into anything simpler. Today, we know that atoms can be broken down into subatomic particles, the proton, neutron, and electron. Now, today, we also know that you have isotopes. These are atoms of the same element with the same number of electrons and protons, but different number of neutrons. Let's now have a look at J.J. Thomson's plum pudding model. J.J. Thomson discovered the electron. He conducted an experiment where he used a very high voltage beam of particles passing through a region of gas at low pressure. He noticed that the particles were attracted to a positive charge. J.J. Thomson used his results to propose a model called the plum pudding model. This is a positively charged sphere with negatively charged electrons spread throughout it. Now, let's have a look at Geiger and Marsden scattering experiment. In their experiment, they fired positively charged particles, alpha particles, at very thin pieces of gold. They expected the particles to go straight through, following the plum pudding model. However, they noticed that some were deflected. These are the results of the scattering experiment. Now, the alpha particles did not pass straight through the pieces of foil as expected. Instead, they were deflected in all different directions, as you can see here. Let's now have a look at Rutherford's model. He called it the nuclear model. Rutherford used the results from Geiger and Marsden experiment to come up with a model. Now, in his model, it has a positively charged center packed with protons, known as the nucleus, and you have negatively charged electrons orbiting it. This later replaced J.J. Thomson's plum pudding model. Let's now have a look at Niels Bohr. In 1914, Bohr noticed that when atoms are heated, they let out specific amounts of energy. This meant that electrons are orbiting the nucleus at set distances. These set distances he called shells. Bohr used this to propose the model with more than one shell for the electrons. Now, Niels Bohr adapted the nuclear model and suggested that electrons orbited the nucleus at specific distances. His theoretical calculations agreed with the experimental observations. Finally, we look at James Chadwick. The neutron was discovered in 1932 by Chadwick. Now, experiments conducted by James Chadwick provided evidence to show the existence of neutrons within the nucleus. He found that neutrons have the same mass as protons and they have no charge. By now, you should be able to describe how new experimental evidence may lead to a scientific model being changed or replaced. A simpler way of doing this is creating a timeline. Now pause the video, get a sheet of paper, and create your own timeline on the key events involved in the discovery of the atom. If you get stuck, just replay the video and fill in any gaps you have on your timeline.